Hi guys, thanks for joining. Welcome to our first virtual meetup. This is Stella speaking. It's nice to see lots of familiar names and lots of new ones too. Firstly, just wanted to say I hope everyone's safe and well with the current COVID situation. I know it's not time for everyone at the moment, but hopefully this will be a welcome session. Very quick intro on IO. Many of you do already, but we're a tech and digital recruitment specialist across the UK. Michael and I have helped organise tonight and we work here as well. Quick intro from Michael and Mark.
Hi, yeah, Michael here. We also work with IO, covering the .NET market for a few years now. And then also we've got Mark.
Hi, I'm Mark. I am the virtual meetup guinea pig for the .NET meetup. Looking forward to seeing how this goes.
Lovely, thanks guys. So just a quick run through the format. Tonight it'll be a 1 hour presentation from Mark. There will also be a 15-minute Q&A session afterwards. You'll also have access to a questions box, so if you have any questions, submit there. There will also be some kind of
Cool. And yeah, so also thanks everyone for joining us. Yeah, we just wanted to say, obviously with everything going on, we want to try and continue the meetups. Obviously have to do it virtually because we know how important they are, and obviously continue that community spirit. Without further ado, I'll introduce you to Mark and he'll look to get going.
Thank you very much, Michael. So hello everybody, and I'll just imagine everybody going, hello Mark, back and laughing at my jokes and all that sort of stuff. So yes, I'm going to talk about moving from WCF to gRPC, because if you've got WCF, that's what you have to do now. It has been decreed from on high. And I've been working in this area for most of the last year in one form or another, writing books and documentation and talking about it and creating a product and so forth. So to start off with, we need to talk about the future of .NET, because it's changed a lot over the last, 5 years. Microsoft suddenly went, we're going to recreate .NET from scratch. And that was, initially it was called Project K when I started using it. And it had a command line tool that was just K, which I quite liked. And then it became DNX, and then it became .NET Core. And now we are on .NET Core 3.1, which is a long-term service release. That came out in November last year. The next version, and this is where it got weird, is .NET 5, which is coming in November of this year. And actually Microsoft just launched preview 1 of .NET 5 a few days ago. And they didn't want to have .NET 4.8 and .NET Core 4.0 out there at the same time. That would just be too weird. And so they just went, we're just going to call it .NET Core 5. And then they had another meeting and they decided they were just going to call it .NET 5, and it would be .NET going forward. And so they're going to continue to support .NET 4.8, 4.9, whatever, on Windows, and they will continue to support that. It's built into Windows, so it'll be there for as long as people need it. But all the development, all the exciting stuff, all the effort and everything is going into .NET 5, which is based on .NET Core. Runs cross-platform on Windows, Mac, Linux, also includes Xamarin and Mono, which are being pulled in and made part of the core thing, Blazor, WebAssembly, and everything else. And the even-numbered releases will be long-term service releases. So we'll have .NET 5, and then .NET 6 will be a long-term service release, and then we'll get a new version once a year around November. So that means that .NET as we knew it, it hasn't quite passed, but it's gone into maintenance life support mode. And there are things that have made the jump to .NET Core as of .NET Core 3, and that will be in .NET 5. So WPF and Windows Forms have both been brought across, although they will only work on Windows, which is a bit weird. But there are also things like Platform.Uno and Avalonia and Blazor and so forth, which you can use to create cross-platform apps for Mac and Linux. But when they made the announcement last year, they said, these are the things that are not coming across. We're not doing web forms. People kept asking about web forms, and they have said, no, we're definitely not doing it. If you need that sort of thing, then we recommend Blazor. We're not bringing WCF, and if you need that sort of thing, then we recommend gRPC. And we're not bringing Workflow Foundation, but there is an open source attempt to implement Workflow Foundation for people who want that. So we've got some polls so that you guys can stick your hands up. So the first one coming up now is just, does your organization have WCF services in production? And I think that's up on the screen now. Off-air poll in progress. The next
Hi, Mark. Not sure if you can see the result there.
I can't. Where's the result gone?
So it's on the audio view. So we've got 42% yes and 58% no.
42% yes, and 58% of people who don't have WCF, but just wanted to know about gRPC, I assume. So that's nice. So then for those people who answered yes to the previous question, we have another question. Are your WCF services, so are they internal, like just between services on your network or from your desktop applications to your servers, or are you using them for public APIs, which you're either sort of just opening up to customers or marketing to consumers, or is it a mixture of both? Oh, there we go. I can see the screen now. And that's come back to me. So mostly internal only, but a mixture of both. Okay, that's great. Thank you all for voting in that. So I'll use that to kind of adjust the material as we go through and call out things that I think are important. So WCF, Windows Communication Foundation, was launched in 2005/2006 at the height of the service-oriented architecture. And it was when people started building what we now call distributed systems. And it was intended to sort of, you can just write C# code and not care about the fact that it's a distributed system. And it actually achieved that very well. And it had two primary modes of operation. You had WCF running as a SOAP service over basic HTTP bindings. And so with that, you could have your .NET service running on a Windows server somewhere, and then exposing that service through WCF, generating WSDL files, and then it could be consumed by people writing Java code or Python code or any other platform that supported SOAP. And equally well, you could use WCF to create a client for a Java service that was exposed as SOAP. And so that was the cross-platform story for WCF. And then you also had WCF with NetTCP. And NetTCP wasn't HTTP, it was a custom protocol and a custom binary data format. And it was really, really fast and could do things that HTTP just couldn't do. But the only problem was that it was .NET WCF code talking to .NET WCF code, and that was it. There was no cross-platform interrupt. Microsoft did actually say, hey, here's the spec for the NetTCP protocol and binary format. They published it and said to the Java people, would you like to implement this? And the Java people went, no. And so NetTCP remains, if you've got a WPF client talking to a WCF service, particularly if you want two-way communication, then NetTCP is really, really good, but you don't get any cross-platform stuff at all, which these days with more and more polyglot systems and microservice environments with lots of different services has become more and more of a problem. And of course, with WCF, they said you don't have to worry about how it's exposed. What they meant was you do have to worry about it, but you have to worry about it in XML instead of C#. And so we had the enormous XML configuration files with the system.service model section, and I repeatedly failed my Microsoft Certified Professional Developer exam purely based on the fact that I couldn't remember the XML configuration settings. So that was WCF, and now Microsoft kind of it's 2019, 2018, 2019, and they're talking about what to bring forward to .NET Core, and nobody's using SOAP anymore. People have moved on from SOAP. It's big, it's slow, it involves lots of XML. I mean, SOAP famously is the thing that went, hey, you know what, XML isn't verbose enough. We need to make it more verbose by putting namespace qualified elements around all the other elements so that sending the number 42 as a SOAP message will use 2 megabytes of bandwidth. That's an exaggeration, but it's not far off. So big laugh, everybody's laughing in my head, which is kind of true anyway, has been since school. So yes, so very little point in continuing to support and push SOAP as a protocol for talking between systems. And .NET Core, the whole point is that it's open source and it plays well in microservice environments, and it's sitting on Kubernetes clusters and Docker containers, talking to Python and Go and Rust and all these things. So the very proprietary NetTCP side of things wasn't really a goer either. And so they made the decision, the very sensible and mature decision, to abandon WCF, kick all their loyal customers in the teeth, and recommend that everybody go to gRPC. And quite a lot of people went, what the is gRPC? gRPC came out of Google, and the G does not stand for Google. It stands for lots of things. It depends which version you're talking about. Google always say it stands for something different. Great, glorious, glamorous, general, I think, was one of the more reasonable suggestions. But it does basically the same things that WCF does, but it does them very differently. And it actually grew out of something that Google were using internally called Stubby. And Stubby was how Google's thousands and thousands of servers in their big MapReduce architecture communicated before anybody else had even started talking about microservices. But Stubby was kind of raw TCP and really, really hairy code. And it supported C++ and Java and Python because those are the things that Google use. And then HTTP2 came along, which actually, again, came out of Google because it was SPDY, and then that became HTTP2. And HTTP2 actually does a lot of the same things, multiplexing and streaming and various other things, that they'd written a bunch of custom code to do in Stubby. And so they went, why don't we rebuild Stubby on top of HTTP2? And because it's the 2000s, we'll make it an open source project and everybody can use it. And so that's what they've done. And so gRPC is based on protobuf, which is another Google project. And protobuf is it's a serialization format and a network protocol, and it's a binary protocol, and it's designed not only to be as small as possible on the wire, but to be incredibly efficient to encode and decode. So as well as not taking up a lot of network bandwidth, it also is friendly to the computer in terms of serializing. It doesn't use a lot of CPU. It tries not to use too much memory while it's working. And so in that way, it's actually very similar to NetTCP's binary protocol. You need to dig into them to find out exactly how similar, but the goal is essentially the same. And Stubby used protobuf as its format, and Google had already open sourced protobuf. And so then gRPC was launched, and it launched on top of that, and it builds on protobuf. So gRPC is a way of doing remote procedure calls, just like WCF. Remember when everyone was saying, oh no, remote procedure calls are really bad and we have to do REST APIs and everything's a document and you're just patching it or putting it or posting it or something. And then we did that for a few years and then when actually, you know what, some things are just remote procedure calls, let's stop. So gRPC, it is remote procedure calls. Just like protobuf, it's language neutral, it's platform neutral, and it has the same goals of being small and fast, and it's reasonably simple. Just like all great technologies, it starts out simple, but it can get quite complicated, and that's where the power comes in. I'm not going to be getting into any of the really complicated stuff today, though. So with gRPC, we have the best of both worlds. We have NetTCP performance, and it is very close. I've done some benchmarks, and they are very close to each other. NetTCP, actually, when I benchmarked it, was a tiny little bit faster, but we were down into the microseconds at this point, so it didn't make a lot of difference. gRPC used a lot less memory than NetTCP. So we have that kind of performance, but with all the interop that we used to get with SOAP. And when I benchmarked gRPC against basic HTTP binding SOAP, it was 2 orders of magnitude faster, and just it was a lot better. And gRPC supports .NET and Java and Go and C++ and all these languages. So everything from .NET through to Python on this list is supported by the core gRPC project and maintained by Google developers and open source developers, but they are part of the core project. Ruby, Dart, all the way through to Erlang, these are third-party implementations based on the extremely comprehensive and well-maintained spec. And you'll notice that it says node.js. So Node is a first-class supported thing in gRPC. And it can be because Node supports all the features of HTTP2 that are necessary. The browser doesn't actually support gRPC natively at the moment. And the reason for that is that gRPC uses certain features of the HTTP2 specification that are not compulsory, but are optional parts of the spec. And browsers don't support them, which is weird, but kind of understandable. It's trailers and things like that. And so to make it possible for browsers to call gRPC services, they created a thing called gRPC Web, which is actually a proxy server that does gRPC client to your service and exposes it in a way that the browser can understand. And so there's a library that wraps around that. And again, it is first class and it's supported, but until recently it meant running a proxy. Microsoft have now, this URL here, gRPC web experiment, they've taken the form used by the proxy server and they've just turned it into some ASP.NET Core middleware so you can expose it as an endpoint in your application. So you don't have to deploy a separate proxy anymore. You can just go, if you can talk gRPC, connect to this port. If you're a web browser, connect to this port, and it's all one application and it all works happily together, which is actually really cool. It's experimental at the moment, but I really hope it goes in. So how do you take your WCF application and turn it into a gRPC application? Well, you start off with ASP.NET Core gRPC. So this arrived as part of .NET Core 3.0, and before ASP.NET Core gRPC, there was a gRPC library for .NET, and it was maintained by Google, and it was essentially p-invoke wrappers around the native gRPC library. So there was a gRPC.dll, and that actually handled all the HTTP2 stuff. It was an HTTP2 server, it did it natively, and then it just mapped the calls through to your gRPC service. And Microsoft said, no, that's not how we want it to work. We want it to fit and feel like it is actually a part of ASP.NET Core. And so Microsoft have created .NET-gRPC, but it's on the gRPC repository. So they are contributing all that code, and all that work is going in as part of the gRPC project. It's not Microsoft's standalone off to the side thing. And so the gRPC team have input into it, and they support it. It's documented on the gRPC site and everything else. And gRPC for ASP.NET Core is a fully managed implementation. So it runs on top of Kestrel. It's maintained by a couple of Microsoft guys. James Newton King is actually one of them. After 20 years or whatever it was, he decided he'd had enough of JSON and wanted to do something that was harder to write a good serializer for. So fair play to him. But yes, ASP.NET Core gRPC, it's ASP.NET Core middleware or endpoints or whatever. It sits in your ASP.NET Core application. It can sit in there with HTTP services, with static files, with Razor pages. It's just part of the ecosystem. And there is a client-side generator for it that uses the .NET Core HTTP client, which is bonkers fast these days as well. And so here is, I'm going to assume that most people are at least a little bit familiar with ASP.NET Core at this point, but this is a startup class. If you've never seen ASP.NET Core before, this is what we have now instead of web.config. And so this is where we say configure services is basically setting up dependency injection. So that's saying there is a portfolio repository and I want to add the gRPC, and it's not adding a single service, it's adding all the services that are necessary for gRPC. And then the configure application is where you set up the pipeline as requests come into your application. They go through this pipeline of middleware until they reach the end, and then they bounce back out again as a response. And so in here, we have use developer exception page, basically says catch any exceptions and generate something nice if we're in development mode, which is like the equivalent of the errors setting in the web.config file. It's been so long since I looked at a web.config file. Then we have app.use routing, which you have to have, and then app.use endpoints, and we just say map a gRPC service to our portfolio service class. And we'll take a look at what that looks like in a little while. So within your application, you're going to have some gRPC specific bits and pieces. And the two main ones are a .proto file, which is a protobuf language file, and a service implementation. So to compare this quickly to WCF, the traditional sort of most common way of doing WCF was you declared an interface which had the service contract attribute on it and operation contract attributes on the methods. And then maybe you had some data contracts, which were your models, which would have data contract and data member on them and various attributes. And then you would create a class that implemented that service contract interface and link that up, and then that would be your WCF application. And so gRPC it's similar, but the language that you declare the interface in is not C# using an interface, it is the protobuf language. And this is what it looks like. So we have a syntax declaration that says we're using protobuf 3. Protobuf 2 is still out there and still used, so we have to be clear about that. We set our C# namespace so that our C# code generation step knows what namespace to put the classes it's creating in. We give the package a name, which we're using portfolio service here, and then we declare our service portfolios, and that has two methods, so effectively operation contracts, a get that takes a get request and returns a get response, and a get all that takes a get all request and returns a get all response. The portfolio service, so the package name and the service name and the RPC names are part of the API definition. So if somebody else came along and used this same proto file to generate a client for Python, it's the package name and the service name and the RPC names that actually are used to form the URL and uniquely identify this service. So that'll be important later on. And you see we've got those get request and get response, and those are models. And so here are some example models. We have a portfolio message, and message is the gRPC protobuf term for an object, a data transfer object. And messages have a name, which is expected to remain consistent. And again, the message name is qualified by the package name. So this would be portfolio service.portfolio. And then we basically say these are the fields in this message. And we have an int 32 ID and a string trader ID. And then repeated is how protobuf does arrays. And we'll come back and look a bit more at that later. And then we have a portfolio item, which is the share ID and the holding and everything else. And so we create these messages and services and RPCs. We define them in our protobuf file. And then in the background, the MS build process running in Visual Studio or from the command line or wherever it might be, uses that to generate base classes, and then you derive from those base classes to actually implement your service. And so this is where you might how you might implement the get code. So we have our portfolios.portfolios base is the base class that's been generated by the gRPC protobuf compiler, and we can inherit from that, and then we just override the generated virtual methods. And these are actually virtual methods, not abstract. So it's one thing I quite like about gRPC. If you don't implement the method, then it doesn't just crash out and say, you don't have to implement it if it's not implemented. And it will automatically throw a not implemented exception for you. So you don't even have to write the code to throw the not implemented exception. It just does it. And so we get our request in here. and we go off to our repository and we get that thing, and then we return a get response. So this part of it is really rather similar to the way you would implement an interface in WCF. So that's nice. So we will come back and dig into that in more detail in a little while. But before we carry on, I do just want to talk about the differences with gRPC and WCF. So WCF would let you declare a method that took a string and a date and 3 integers and returned an array of decimals. And gRPC doesn't do that. With gRPC, you have to declare a message type that will be the parameter to your RPC, and it will return a message type. So it can't return the scalar value types. It can only return custom messages. It has to return a message, so there is no void. It always has to return something, and so you use an empty message. And there are protobuf specific data types, so you can't just go, I'm going to use GUID, for example. So you have to use a limited set of data types that protobuf understands and then build everything else on top of those. Here are those data types. We have integers. There are 10 kinds of integer in protobuf. There's int32 and int64, and then there's unsigned int32 and 64, and then there's signed int32 and 64, and you might think, why is there, surely int32 is already signed, why is there a specifically signed int32? It's actually to do with the way it's encoded. So if you have an int32 that is generally going to be positive, but may be negative, then do it as an int. If you have one where you know that it's often going to be negative or positive, so like a stock ticker that shows you whether it's gone up or down, then the signed int actually is a slightly more efficient encoding. And this is the nice thing, you actually get to think about how these are being encoded and optimizing for that. And then you have fixed 32 and 64, which will always use 4 bytes for the 32-bit and 8 bytes for the 64-bit. So if you know that these numbers are big, again, it's actually more efficient to use the fixed encoding. And signed fixed 64, I don't even know. I got lost at some point reading through that. And then there are 5 other scalar value types: double, float, bool, string, and bytes. Bytes being a byte array in C#. Everything beyond that is just declared using messages based on those fundamental types. And that includes what they call the well-known types. So these are, they're not native values, but they are built into protobuf. So you don't have to go and get them from anywhere. So datetime and datetime offset equivalent is timestamp. The time span equivalent is duration. There is an any type, which is a wrapper around any protobuf message at all, but only messages. You can't put like a string or an int32 into an any. And then we also have int32 value, float value. So for every one of those scalar types, there is a well-known type with value on the end. And as C# programmers, you can primarily think of these as being nullables. So int32, if you don't set it, it'll be 0. It'll always be there and it'll be set to 0. So if you want a nullable, you use int32 value, and it does actually compile to a nullable int or a nullable float or a nullable bool. They also have string value, which is nullable, but string anyway. These, like I say, they're built into protobuf, but they do require an import statement. And that looks something like this. Let's find some actual code. So here we have an application that has been converted from WCF to gRPC. I'm going to make this, I'll make it a bit bigger, even though you're all sitting at your desks and you can see it, because maybe there are people watching on phones or something. So I'll make this a little bit larger. So this is a real service. It's not a real service, it's one I made up, but it's a hotel service, and you have a get available rooms. And so you can see at the top here, I say import google/protobuf/timestamp.proto. And then in my get available rooms request, I use google.protobuf.timestamp, check-in date and check-out date. We're using whatever you like to call this, snake case, train case, Python case, but the protobuf standard is to use these underscored lowercase names. The generated C# will switch that to regular Pascal case for you. It's just that if somebody else goes, if you put Pascal case in here and then somebody goes and generates Python code, for example, it will keep the Pascal case, and the Python people will be banging on your door going, why are you making me use a sensible, readable format for my namings? So yes, we'll come back to decimal a bit later on. But if I go a bit further down, you can see we have an all rooms request. So this is worth noting. RPCs, it is one and exactly one parameter. And it has to be a message type. So if you don't have any parameters, you have an empty message. And if you don't return anything, you have an empty message. The reason for this is gRPC is one of the few API creation systems I've worked with that actually thought up front about the problem of changes over time, which is also why all of these fields have this number on the end. So if you were to change the signature of an RPC like you would in WCF, excuse me, to take an extra parameter, then that would break all the existing clients of that endpoint. They wouldn't be providing that parameter. So what gRPC does and what protobuf does is it says you have to provide a request, even if it's empty, so that if later on you decide that you want to add a parameter to all rooms, you don't change the signature of the RPC, you just change the message that you are sending to it, the parameter message. And you can change the parameter message safely because of these numbers at the end of every line here. So check-in date is field number 1 and checkout date is field number 2. And these numbers are unique, and they, along with the type, are used as part of the actual binary encoding. So if I decide I want to add fear of heights Boolean or something to my get available rooms request, so that they don't get put above the second floor, then I can add that here. But more importantly, if I decide I want to remove a field from a message, I can mark that field's number as reserved so nobody can reuse it, and old clients can talk to newer servers. Weirdly enough, it also means that newer clients can talk to older servers. Older servers will just ignore any field numbers they don't know about, and newer servers can check to see whether that field is set and behave differently accordingly. So you have really good API, it's not API versioning, but it's API resilience to change. This is not a gRPC requirement, but it is a best practice. You'll notice that, so where we have get room, and we have a get room request, which takes the room number, and that returns a get room response. And you see here that that's just got a single field, which is room, and I've called that value for some reason, and that is just field number 1. Now, I could just return room directly from here, so I could just change this so that it just returned room. And I could have lots of different RPCs that all returned a room object. It's a good idea not to do that and actually to have a dedicated response message for each RPC, so that, again, if you decide that the get room response wants to include some extra information, you can add that to the response message and not to the room message, and avoid breaking things and avoid adding unnecessary fields that aren't needed on other calls and all that sort of thing. Okay. As you noticed in one of those types in there, it had a repeated prefix on one of the fields. That is how protobuf does arrays and lists and collections. It makes no distinction because it is just a format for you create the object, you serialize it, you send it over the wire, it deserializes at the other end. You don't have to worry about whether the list is mutable or the array can get bigger or whatever. It's just repeated, so we don't worry about it. There is also a map type, which is a direct analogy for dictionary of T key, T value. It supports enums, and those map pretty directly to C# enums, except enum value 1 always has to be set in a protobuf enum. And it also supports something called one-of fields, which we'll come back to in a little while. So, making reasonable time here, about on target. So we have multiple gRPC modes, and for this there is another quick poll question to find out whether Michelle has gone to sleep or not. No, she hasn't. Excellent. So for those of you who are using WCF, are you using basic HTTP with SOAP or NetTCP or a mixture of the both? And if you're not using WCF, just don't answer. So mostly basic HTTP with SOAP. Okay, that's great. Then for the most part, most of you will be happy with the simplest gRPC mode, which is really nice and easy to work with. So we basically have, let's call basic HTTP binding a request result. So you send the server a request and it sends you a result. And gRPC has exactly that as its kind of default out of the box behavior. You create a request object, send it to the server, does something, sends you back a response object. It also supports streaming, which I mentioned briefly earlier on in the context of HTTP. So WCF, with certain bindings, you couldn't do this with basic HTTP, but you could with NetTCP and a couple of the more obscure bindings. If your WCF method returned an IEnumerable, it would actually write the results over the network as it went through the enumerator. It avoided building data sets in memory, and it meant you got the first result very quickly on the client. gRPC supports that with something called service streaming. And actually the get all rooms response here, you can see we have this stream keyword. And that's basically saying this request will open up a stream and then the server will just fire rooms back as and when it gets them. It's great for things like tickers as well. So you can create a Microsoft's kind of default demo application for this is a weather ticker where you connect to it and it just sends you updates going, still not raining, still not raining, still not raining. It's raining, it stopped. So you can use it for asynchronous communication, or you can use it to avoid building a massive data set in memory. If you've got a data set that's going to be a gigabyte, you don't want to build all of that up in memory before you start serializing it. So you can use it for that as well. You can do that the other way around as well. So if you've got an enormous quantity of data that you want to send to the server, this works really well for file uploads, where you don't want to kind of use form chunking uploads and everything else. You just want to go, here's more bytes, here's more bytes, here's more bytes. It's an incredibly efficient way to do file uploads. So you can do, instead of having the stream on the response, you can actually put the stream prefix on the request, and that will open a stream, and then the client just sends as much as it wants to the server and closes the stream when it's done. And then we also have full duplex in WCF, which was where the server could actually, using a callback contract interface, could call methods on the client. And that was used for sort of chat applications, stock tickers, all sorts of things. And gRPC, you can put that stream keyword on both the request and the response, and you can do bidirectional streaming, and you can actually convert a WCF application that was using full duplex to a gRPC application using bidirectional streaming. Also, WCF had an MSMQ binding, and there is no gRPC equivalent for that. And I think MSMQ has been deprecated now as well. Basically, if you want something to go on a queue, put it on a queue. Don't pretend it's an API call or something. So, request response. This is the simplest one, and I'm just going to very quickly go through an example of a WCF application. So this is the hotel application as it was in WCF. So we have our WCF application here. We have our hotel service. This is a service contract with operation contracts. It has get available rooms, get room. That takes a date time offset for the check-in date and the check-out date. Room takes an integer. Rooms takes an array of integers. And all rooms returns an IEnumerable. So with the correct binding, this would be doing a streaming approach. And then we have our hotel service implementation, which is wrapping, which is calling through to a data class, which is down here. We have a data contract with data members with the number and the floor and the name and the price. And you'll notice the price is a decimal. And our room data class here is just completely faked. Bonus points for everyone who can tell me why the room numbers are 101, 237, and 1408 in the feedback at the end of this virtual meetup. And yes, so, and then in our web.config, we had all our service behaviors. So we're using basic HTTP binding because I created a WCF application and I didn't change anything. So that's it, it's basic HTTP binding. Okay, so migrating this to gRPC involves taking our service contract and rewriting that as a .protobuf file, and taking our data contracts and rewriting those as protobuf messages, and then moving the implementation code here. So instead of being an implementation of an interface, this needs to be called from inside our gRPC service implementation class. And that is what this is. So this actually is one of the test applications that I use for Visual Recode, which is my Visual Studio plugin that just magically does all this stuff for you. And so this uses Roslyn to read the WCF application and generates the equivalent gRPC application. So it's created the proto file directly from that interface and from the data contract in the case of the room type. And you'll notice that I have a custom types.decimal value. And the reason for that is that for all its integers, protobuf natively doesn't have a decimal type, and the well-known types don't have a decimal type. So the only number format that you can use is float or double. And as anybody who has ever said, hey, floating point implementation, what's 5 times 4.99, $4.99, which comes back as $24, 9.9499999999999991 cents. I'm guessing a few of you out there work in finance and you're not that wild about using doubles or floats to kick your values around. But it's actually really easy to create a decimal message. This is the one that I've opted for, and it's got an int 64 of the units and an int 32 for the nanos. And so the nanos are the 9 digits to the right of the decimal point, and the units are the whatever it is, 64-bit digits to the left of the decimal point. And we've got lovely comments in there as well. And so you can ship this proto file as part of your API definition to people who want to consume it, and it will generate this decimal value type in Java or C++ or Go or whatever it is, and it's got documentation in it to tell people exactly how it works. So that's quite nice. If units is 0, nanos can be positive 0 or negative. It doesn't say what to do if units is negative 0. And maths people will back me up, that is a thing. When protobuf generate the classes for these types, they generate them as partial so that you can add functionality to them that will survive regeneration. So the actual generated code incidentally goes into object debug, and you can see here, this is the generated code. It's not something you want to be mucking about with. Don't go in there, don't look, it's best not to know. It generally works quite well. But we can extend those generated types, and so here I've got a decimal value type, and I've just added in implicit operators to convert it to and from the built-in decimal type in C#. So as far as you're concerned, it is just a decimal type. So that's the message type there. I just copied across the hotel service implementation. It's perfectly fine. It runs in .NET Core 3.1. It's not using anything complicated. I also copied across the service contract and just commented out the attributes, or rather my tool did that for me. And I copied across the Rune data contract and commented out the attributes, and I copied across various other things. And then the implementation of the class here, so this is coming from hotel service base, which is the protobuf generated class, and then that pulls in the iHotel service and literally just breaks the request down, calls through to that. So this is generated by a tool, but if you haven't got a huge number of these things to convert, this is a perfectly valid way to go at this. And if you have got a huge number of these things to convert, then the tool's not very expensive. But yes, so we call through to the service contract using the values from the request message, and we just return the result back as the response, and we catch any exceptions and rethrow them as RPC exceptions. With the exception of all rooms, which was the thing that returned IEnumerable, and the gRPC method here. So each method, basic request response, just gets the request type as a parameter and then server call context. This is the equivalent of HTTP context. So there is no static context or request or response type on our gRPC class. So if you want to get any of the meta information about the connection or the call, then you get it from here. And And one of the things you can get from there is the HTTP context, actually, because this is just running on top of Kestrel. The all rooms, you don't return a stream, you just return an empty task. It creates the stream for you, and then you just write into it. And so you just say for each thing in all rooms, create a response and write it to that stream there. And that's basically it. We hook up our services, so we add our hotel service, service contract interface and implementation in configure services, and then those will just get created for us as calls come in. We map our code through to there. And for this particular instance, which doesn't use any NuGet packages or libraries that depend on .NET 4, this makes life very easy. If you're using SQL database or a database where the equivalent ADO.NET implementation is available for .NET Core, like PostgreSQL, MySQL, something like that, then you should find this a fairly straightforward migration as well. If you're using Entity Framework, then you, as long as you upgrade to Entity Framework, I think it's 6.3, that is actually now supported on .NET Core 3.1. And so you can use the old style Entity Framework, the full featured, full fat EDMXs and everything else. You can use that with .NET Core 3.1, and that will be supported moving forward onto .NET Core, or rather .NET 5, .NET 6, until such time as EF Core catches up. But apart from that, it's just a standard gRPC application that wraps around your old WCF implementation code, so you can bring that across quite easily. Hello. Okay, so you're seeing that. I'm not actually seeing. There we go. So server streaming is the IEnumerable example that I just showed you with the all rooms. So that just returns a stream there. We also have bidirectional streaming. And so for those people who are using NetTCP and maybe doing full duplex bindings and sessions and everything else, you can achieve that, although it's a bit weird. I don't have a lot of time to go into it at the moment, but I will send some show notes at the end. But essentially, what you do is you create, is it that one? Yes. So we have okay, that's just weird. Why have you opened that? My code has gone mad. Open recent gRPC recode. Sorry, I was doing really well, and then it's all gone a bit strange. Oh, folders, that's what I was doing wrong. So recode sandbox, open folder. Recode sandbox. I do apologize, I thought I had this open. Duplex calculator core. There we go. So yes, effectively a duplex system works by opening a stream from the client to the server and another stream from the server to the client, and then depending on which method the client wants to call, it sends a different message. And so we calculate a duplex action and a duplex callback. And so our duplex action has nested messages for all the things that are possible. So clear, add to, subtract from. And this is where that one of type that I mentioned earlier comes in very useful. You can say only one of these fields will be set. So if I set the clear field, I know the others aren't set. And if I then set subtract from, it removes the clear field. So it knows what type it is. So it's essentially, it's like an any object, but constrained to a specific set of types. And then we have a callback as well. And then we just send these streams in either direction. And the implementation for this is a little bit hairy, but it basically has a request stream, and we say await for each, because this is .NET Core 3.1 and C#8, and we can read all the messages off there, check to see what it is, and then invoke the relevant duplex message accordingly, and send callbacks by passing callback messages in the other direction, which is basically the same as what WCF was doing. It's just you're doing it a bit more directly. Okay, so a few quick things to finish up. Security, .NET Core gRPC security, because this is built on top of ASP.NET Core and embedded in that, it just uses the standard ASP.NET Core authentication authorization. It uses the same pipeline, it uses the same services, and use authentication, use authorization. You can use identity server. It's all based on bearer tokens at the call level, so JSON Web Tokens or some similar token. It also supports certificate authentication, so the client presents an X509 certificate, which is done at the HTTP level. There is no Windows authentication in gRPC because there is no Windows authentication in HTTP2. Windows Auth, Kerberos, whatever that was, you can't do it in HTTP2. Not sure why, you just can't. So that's gone. So if you need Windows authentication, you need to set up a federation server and then go to that federation server to get a token that is based on the Windows Auth and then pass that into your gRPC service. In production, you can continue to run this on Windows, although you can't run it in IIS at the moment because IIS, like web browsers, doesn't support the necessary HTTP2 features. That also is causing problems with running it in things like Azure App Services, but you can run it in Docker, you can run it in Kubernetes, you can run it on top of a service mesh, and that means you can run it anywhere. So if you've got app services, you can run it in a Linux container in app services or in a Windows container in app services as well. So that works okay. Quick talk about migration strategies. So to not break your clients as they go along, you can create a backward compatible wrapper around the gRPC client, and you can see here that there's a calculator duplex client here. This again was generated by Visual Recode, but this provides a wrapper around the gRPC client that matches the old interface from the WCF application. So that's a good strategy for when you've got .NET clients. It's particularly good if you've got like a WPF or a Windows Forms application that's currently on .NET 4.8 and you know you're going to be migrating it to .NET 5 or .NET 6 down the line, then this backward compatible shim, you can kind of put that in and then it'll continue to work for you, and it uses a different client generator for the .NET Core clients. For those of you who've got external customers using your SOAP API, that's where it sort of gets really tricky, because you can't just go, and now we're gRPC, and all of you have to go off and rewrite your consumers. But in the same way, and actually with very similar code to building a client shim, you can migrate your service to gRPC and start the process of pushing people to migrate over to it, explain to them why it's better, why it's going to be more performant for them, maybe pass on some of the cost savings of running a one-core Linux container instead of a quad-core Windows server. So you can create a WCF service that just proxies through to your gRPC service, and then you've got all the flexibility, whatever WCF bindings you were using, whatever authentication mechanisms you were using, you can continue to use those. You can continue to use that same amount of configuration, that same kind of configuration on the proxy, and then once you monitor the traffic that's going to the proxy versus what's going to the service. Once traffic to the proxy drops to 0, then you can just quietly decommission it. If traffic to the proxy refuses to drop to 0, just slow it down by 10% every day, and eventually people will get the message and move across. So obviously, to run the WCF proxy, you do still require Windows servers. Finally, but most importantly, if you are going to migrate your WCF application to gRPC or any .NET 4 application to .NET Core or .NET 5, first thing to do is make sure your NuGet packages are up to date. Make sure there is a version of that NuGet package that supports Net Standard or .NET Core App 3.1. If there isn't, try and find an alternative package that solves the same problem that you can use instead. For WCF specifically, remove the kind of references you've got to operation context throughout the code and try and streamline those. If you're using WCF specific features and using a lot of operation context.current, then try and find other ways of doing that. Clean up your code, get rid of the dead classes, get rid of all the commented outlines, get rid of all the stuff, the tech debt that's accumulated over the last 10 years. And finally, it's a really good idea if you can, WCF in .NET 4.7, 4.8, you can declare your interface with returning task of something and implement everything async. It will be easier to migrate across to gRPC if the code that you're migrating is already asynchronous, because gRPC insists on asynchronous. I wrote a book for Microsoft called gRPC for WCF developers, which you can get from the .NET architecture subsection on Microsoft's amazing documentation site. I've mentioned it. I'm not, this isn't a sales pitch, but I've made this thing and I'm actually quite proud of it, and it may possibly just be the best thing I've ever built, and it's out there. At the moment, Visual Recode will take your WCF application and recode it to ASP.NET Core gRPC. We're also going to add in support for taking WCF and turning it into just a regular HTTP web API. You can check that out at visualrecode.com. Version 1 is available now. There's a 14-day free trial. It's entirely possible that it could do 18 months of work for you in a week. So on that basis, I think it's very reasonably priced. If you want to get in touch with me, and this includes if people couldn't get into the actual live user group and want to ask questions after watching the video, then twitter.com Mark Rendle is usually the best way to get in touch with me. My direct messages are open. There's also Visual Recode on Twitter. You can connect with me through LinkedIn, and you can go to visualrecode.com to find out more about the project. That's it from me. That was so weird. Thank you all very much for coming. And yeah, I hope that worked for everybody.
Cool. So first and foremost, thank you very much, Mark. And also thank you to everyone for attending this evening. And if you're watching this back, apologies you weren't able to get into the room. We had some last-minute technical issues, but we will be getting this out. Will be recorded. So I know you mentioned about getting your questions in to you. So we've had Michelle just sent me over a few. We also, Mark, had a question come from the LinkedIn group from Pavel, who wasn't able to attend. So I'll just go through those questions now, if that's okay.
Okay, yeah, that's great.
Cool. So Michelle has just sent it to me. Where's it gone? So the first question we have is, what about core WCF?
Yes, so core WCF, Microsoft Microsoft did some experimentation to see how difficult it would be to actually migrate WCF to .NET Core. They didn't just go, we're not doing it. And they decided that the effort was too much and it wasn't a good use of their time. So they donated the code that they wrote as part of that kind of Spike prototype to an open source project, which is actually mostly maintained by one of the original WCF developers. And it's there, and it's on GitHub, and it's a worthy effort. But it does appear to be it's mainly Matthew Connew who's maintaining it. It's unclear how soon it's going to be production ready. My personal thing is, like I showed at the start, nobody's doing SOAP anymore. NetTCP is .NET only. WCF is really not a product designed for 2020. It's a product designed for 2006. And so, yes, it's there. It might be a good stepping point to get onto .NET Core, but I don't think it's a long-term solution.
Cool, thank you. The next question we have is, when should you use gRPC instead of regular HTTP API? I got a bit tongue twisted there.
Great. Yeah. So gRPC, the things it's really good for, microservices talking to each other in a cluster, or services talking to each other in a distributed system, where the emphasis is on speed and performance and keeping things fast and small. If you want two-way streaming tickers and that sort of thing, then gRPC is great for that. Whereas HTTP, you'd be looking to use something like WebSockets. If you want to do it from the browser, then you might look at using SignalR. But gRPC between services. HTTP APIs, certainly for public APIs, I would say having an HTTP API with just JSON objects is a much more friendly way to publish an API. What Google are actually doing now for a lot of their public APIs is offering both. So you have an HTTP JSON API, and there's also a gRPC version of the same API. And you can do that. You can run them both in the same application on the same port. If someone connects with an HTTP put or a post or a get, then it goes to MVC. And if they connect with gRPC, then it'll use that. But gRPC, when performance matters, or when you need one of the features it provides.
Cool. And does it support VB.NET?
No. ASP.NET Core right now doesn't support VB.NET. You can write class libraries in VB.NET and then consume them from C# projects. So if you've got a whole ton of VB.NET code, then you could bring it across and put it into class libraries and then reference those from C#, gRPC, or ASP.NET Core projects and use it. But no, gRPC itself will only generate C# code. It won't generate VB.NET code for you.
Cool. And am I going to have to migrate to something else new in another 10 years?
Yes, but that's kind of the fun, isn't it? No, I don't know. Who can say? Somebody might come up with something that's better than gRPC. In 10 years' time, we might be encoding everything by adjusting the spin of charmed and strange subatomic particles to instantly have the same effect on another particle on Mars or something. Yeah, you know, you can never guarantee the future of anything. Right now, gRPC is what the vast majority of companies are using for microservices, for distributed services, for mobile phone applications as well. gRPC works great for bandwidth constrained mobile devices. So there's that.
Cool.
But yeah. you know.
And
right now.
lastly, just sorry
Yes.
to interrupt. And I was going to say, lastly, just from Pavel, who will be watching back on the recording, asks authentication using TOTP, which I assume is can you do this, and versioning of contracts when removing fields between microservices.
But so if you remove a field from a message, you just have to mark the field number as reserved. There's a reserved keyword, and then you can either have just a number or a comma separated list of numbers or a range of numbers. But the main thing is if you had field number 3 that was zip code, then you take it out. You want to make sure that nobody else comes along and puts in a new field 3, which is now county. And so you have to reserve that field number. Yeah, that keeps the messages safe between versions. So yeah, never reuse a number. Even if you're convinced that nobody out there is still using a version of the client that was using the old version of that number, still don't use it. The numbers can go all the way up to whatever an unsigned int 64 is. So you're not going to run out. And TOTP authentication. So that's the one-time password thing, isn't it? If that one-time password generates a token, if you can use that one-time password to generate an OAuth token or a JSON Web token or an OIDC token, and then use that, then yes. But generally, you do your authentication another way using an HTTP API or identity server or something like that. You get the token and then you use that to authenticate the gRPC calls. You wouldn't generally put sort of a login method inside the gRPC itself.
Perfect, thank you. And I think just one last mention, Luca DeMarco may have guessed the numbers you mentioned earlier on. So room 101, Nia's apartment in the Matrix. Room 237 is room 237, the documentary movie about The Shining. Yeah. And room 1408 is hotel room in 1408.
In Stephen King's, yes, in the Stephen King book, short story. So yes.
So bonus points to Luca DeMarco.
Bonus point to Luca DeMarco. Well done, mate.
But yeah, thank you very much, Mark. Genuinely, really appreciated. As I said, thanks everyone for coming this evening. I don't know if you had anything else to add, Mark, at all.
I just realised one thing I forgot to mention. Went back when we were talking about data types. GUIDs. There's no GUID. Use string. Don't muck about. Just use string. Apart from that, I remembered everything else I wanted to say. Yeah, I hope that went well for everybody. I hope that worked and people were cool. Informed and entertained and educated. And thank you very much for having me.
No worries, thanks for coming. And I think if you want any more information about sort of upcoming virtual meetups on the IO Associates website, but yeah, generally, thank you everyone for coming. We'll follow up on any of the questions we didn't get to ask on email. But yeah, thanks from me and Stella, from IO, from Mark and Michelle. Yeah, really genuinely appreciate it, and we look forward to doing this again while we're all in lockdown.
Yes, yeah. Thanks very much, everyone, and we'll be releasing our next details for our future meetups shortly. So just stay tuned, and hope everyone can stay safe and well.
Yeah, take care of yourselves, take care of each other.
Amazing. Absolutely. Thank you very much. Cheers,
Thanks,
everyone.
Mark. Thanks, everyone.
Thank you.
Bye.